Unit 5, Topic 4, Writing Exponential Equations. The key thing that I want you to think about is this equation here. Remember that the first number is your initial number, and then how we're going to determine whether things are growth or decay is based on the idea of V. So here's the way I want you to look at it. How do you know it's a growth? If the B is above 1, we know that it's growing. So here is the only number that I care about. It's not the initial number, that's my initial population. It's whatever is to the power of x. So because the number was bigger than 1, 1.2, we know it's a growth. Here's the number 3. That's an example of tripling. So we've had a few questions on previous assignments that had a triple. In terms of decay, again, it's the same idea. What is happening to the number to the power? If that number is less than 1, a third is really, if you were not sure, 0.33 forever in your calculator. And here is 85. Because those are under 1, it's decay. Looking at your worksheet, the very first question is about an algae bloom. But right off the bat, I can see the 1/3 is in this equation. This is an example of a decay. So if it helps you to remember, write it down. And remember that your graph should be dying as it goes over. The important thing here is they just want us to fill out the chart, make the graph, and then can we answer this last question? And this is why writing an equation is very helpful. So to get you the very first one, I'm going to choose the number 2 as just a random, and again, remind you how to type that in. So my initial point is 240. I'm all about the parenthesis. I type in 1 divided by 3, close the parenthesis, hit the caret, and I'm going to type in the number 2 I chose, 26.6. As you type in these numbers, remember the initial number, that's where it starts at. And we learned on our previous lesson, anything to the power of 0 is equal to 1. So 1 times 240 is 240. This number should go down. It'll go to 226, down and down. Make that graph happen. As you look at question C, we see, well, okay, Gary, yeah, we know 2 and we know 3, but what about any point in between? That's the power of the equation. We can come in here and type in any specific piece of information, in this case 2.5, into our calculator to get that answer. So if we already had it typed in, 240, 1/3, and now I just don't want to know 2, but I want to know 2.5, the calculator can tell us exactly, hey, that's 15 point, I'm going to say 4, because the 9, the 9 is going to make the 3 into a 4. I really want you to be able to take on these questions on the back, which is just identifying, is it a growth or is it a decay? Again, is the number bigger than 1? Well, if I'm taking 1 plus a number, definitely know that's a growth. If I'm taking 1 minus a number, it's got to be a decay. So look at those numbers to the power of x and determine growth or decay. Initial value, it says 100. It says 8282. Do you know why Gary likes that number? And the last question is, what is the rate or growth of decay? Well, this is how far from the number 1. So in the very first question, they're helping us out here. It's really 0.05 away. And in terms of a percentage, this would be 5%. Because this number is zero point 0.2, again, to make a number a percentage, I went over 2. If I go over 2 here, that space means 20%. In this case, because it was a decay, it was going down, whereas in the first one, it was going up. Just picking one other random question, I'm going to look at E. How far away is 65 cents from a dollar? Well, 1 minus 0.65 is really 0.35. And if I move that over 2 spots, 35%. The questions below are word problems associated. Again, always start with your initial population. Population was 3,600. Ask yourself, is it a growth or a decay? And then you're going to take the percentage and you're going to add. Now remember, 4%, if I go back 2 spots, is 0.04. So right here would be 1.04. And in this case, the X is the number. They actually give us an idea though. We're going from 2010 to 2025. So I don't want to put an X. How many years are in between there? We would say 15 years. If we calculate that on our calculator, 3600, 1.04, up arrow, 15 years. That's the population of the town now, 6483. Because we're talking about people, I'm not necessarily going to include any decimals. Last question I'm a fan of, 1982. In Starbucks, there was really only 5 stores that existed that year. So initial number is 5. Obviously, there's a lot more Starbucks today, but it's grown by 25.6%. So 1 plus 0.256, and then you need to determine how many years has it been since 1982, for this question says 2020. And once you get that, you're going to find out how many Starbucks are in the world in 2020. Good luck.